Welcome my friends, we are studying mathematics, first term of grade number 6. We are studying unit 7, measures of central tendency and spread. And this is lesson number 3, exploring median, mode and outliers. Let's go. First we start with learn exploring what median, mode and outliers. We have something called central tendency. Okay, this central tendency we have mean and median, and finally we have mode. Okay, we learned before how to find the mean or median, but it's new for us, something called mode. So what's mode? Mode just a value between some values, okay, that occurs most often. What does this mean? That means we have these values, okay. You know that 8 is repeated twice, okay, so 8 is the mode. For these values 7 is the mode, but we have another mode as 3 because we have 2 3 and 2 7, so 7 and 3 called as mode. So maybe you find one mode or two values as mode. If you have two values as mode, you called it bimodal. Okay, look here, 15 16 9 18 11. There is no mode. There is no mode here, no mode for these values. All of them are different values. Okay, now I can find the mode from plot graph. Look here, for this plot graph we have from 10 to 80. Okay, which value is the mode for this plot graph? It's the biggest one. We have here 50 has 1 2 3 4 5 6 times. 6 times 50. Okay, so 50 will be the mode for these values. Okay, why? Because it has the greatest frequency. Okay, so now I can find the mode from any values or from plot graph. Go to next. Now let's learn about something called outlier. Outlier are values that lie outside, is much smaller or much larger or larger than the most of the values instead of data. To understand what outlier, we have two examples, as values and as plot, dot plot. Okay, now look for these values. Here we have 24 23 7 28 26 29. Okay, now which one is the mode? There is no mode here, okay, because I have no repeated value. But what is the outlier? Look here, 24 23, it's close, 28 26 29. All of these values are close to each other, but here we have what? We have 7. 7 is so far from all of these values, so we called 7 what? We called it as outlier. Here we have from 0 to 100 all of these dots at right side, but there is one dot here for 10, but all of these values start from 50 to 100, so 10 is so far from these values, so I called 10 as what? As outlier. Okay, now we can find any values for two mode, right? Okay, also we can find two outlier. If you have two mode, it's bimodal. Maybe you find two outlier value. Look here, we have 25, 29, 32, 30, 50, 50 or 85, 33, 26, 28, okay, and here we have 3. So this is 20, 20, 30, 30, 20, 20. All of these values between 20 and 30, okay, but this value are 85. There is big gap between 20 and 30 and 80. Also we have just 3. So these values 3 and 85 called outliers. So this group of values have two outliers, 30 and 85. Go to next. To understand what we are studying here, let's have this example. This example number 1. The example here asks us to find mean, mode, median, and outliers. These 4 concepts I need to find it for these values. So I have these values 19, 3, 5, 7, 4, 5, and 6. Okay, to find the first mean. How to find the mean? I have 3 ways. The first way we called it as balanced point. You remember? Okay, and the second way we learned before called fair share. And the third way called the role. Okay, when you have group of values, use what? Use the role to find the mean. So what's the rule? The rule was to the sum of values. That means I need to add all of these values together, 4, 5, and 6. Divided by what? Divided by the number of them. 1, 2, 3, 4, 5, 6, 7. So divided 7. Now that's equal. Please add with me. We have here 19 plus 3, 22, plus 5, 27, plus 7, 34, 38, 43, and plus 6, we have 49 divided by 7. 49 divided by 7, that's equal 7. Okay, 7 by 7 equal 49. Now the value of the mean is 7. That's the first question. Now to find the mode. The mode is the most repeated value. Look here, what is the repeated value? Just 5 and 5. So 5 is the mode of these values. Okay, now I need to find the median. We learned it before. To find the median, what we do to find the median, we arrange all of these values first, okay, and delete one from right and one from left. So to find the median, start with the minimum one, 3, 4, 5, also 5, then we have 6, 7, and finally we have 19. So to find the median, delete one from the right, one from the left. The same. Now you find what? You find the value of median is 5. So we mean is 7, mode is 5, median is 5. Now the last concept we need to find outlier. To find the outlier, look for these values 19, 3, 5, 7, 4, 5, 6. Of course, you know that 19 is so far from of all of these values. All of these values are close together, but 19 is so far from them, so the outlier here is 19. Now we finished point A. Let's go to point B. The same question with point B. We have here dot plot. Okay, now I need to find the mean. Using what? Using roll or using balance point or fair share? The ordinary way to use the roll. So the roll is to add or to the sum of all values divided the number of them. Now here we have, what's the values here? We have 2, 4. So I have 4 and 4. How many 6? 1, 2, 3, 4. 6, 1, 2, 3, 4, 6. And 3, 8. 1, 2, 3. And just 1, 16. Now I need to add all of these values divided by the number of them. What's the number of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by 10. Now add them. Add with me. 4 plus 4 equal 8. Okay, so we have here 8. Okay, now we have 4, 6 is 24. We have 3, 8 is 24. And finally we have 16. If you add 24 plus 24, we have 48 and 16 and 8. Now add with me. 8 plus 8 equals 16. 16 plus 16, that's equal 32. 32 plus 40, we have 72. Okay, now we have 72 is a sum of all values. Now the mean equals 72 over 10. 72 over 10, 72 is not divisible by 10, so I will make it as decimal number, so it's 7.2. 7.2, that's the mean value. Okay, now I need to find what? The mode. What is the mode here? Look with me. The mode here, we have 2, 4, 4, 6, 3, 8, 1, 16. The greatest one here, the greatest frequency here for what? For 6. So 6 value is the mode for this graph. Okay, now let's find the median. To find the median, okay, to find the median, I need to what? To arrange this value from the smallest to the greatest. It's already arranged, okay, ascending. So I need to delete one from right, one from left, one from left, one from right, right, left, right, left, right, left. Oh, we have 2, 6. Okay, so add these 2, 6 to each other, divided by 2. 6 plus 6 equal 12 over 2 equal also 6. Now the value of the median is equal to what? Equal to 6. Last thing, outlier. So what's the outlier here? Of course, all of these dots like a group, but this dot is so far from them. There's big gap here. So 16 is your outlier for this group of values. Okay, now we finished example number 1. Let's go. Now we learned about the median and the mean and outliers and the mode. Okay, now we need to find some relationship between what? Between outliers and median and mode, and that's how outlier affects the median and the mean of the following values. Note with me, we have here 1, 2, 3, 4, 5 values. Okay, that's obvious that 5 is the outlier because all of these values are close to each other, and 5 is so far from them. Now I know that the outlier here is 5. Okay, now I will find the median in two cases. The first case with outlier and the second case without outlier. What's the meaning of without outlier? That means I will delete this 5 and find the median just for these values. First case with outlier. To find the median, I will delete one from right, one from left. Okay, you find that the median equal what? Equal 90. But if you deleted this 5 and work with these 4 values, you will find the value as 91.5. Okay, what you note? We noted that the outlier has weak effect on the median. That's mean the first case with outlier is 90 and without the outlier is 91.5. These two values are close to each other. That's mean if you delete outlier or work with outlier, the values are close to each other. But that's for median. But for the mean, let's try the two cases. For the first case with outlier, we have the mean equal 74. When you delete the outlier, so the mean is 91.25. So the mean in the first case 74 and the second case 91.25. That's mean what? The outlier has great effect on the mean. So the median no effect or just weak effect for the median. But for mean it's a great effect. Now we can conclude that we have some data here. Okay, if you have some outlier, I will use what? Median or mean? No, with outlier I will use mean. Why I will use median? Sorry, because median there is no effect for outlier. But if my group of data has no outlier, without outlier I use what? I use the mean, because the mean is the best way, okay, to describe set of data. Again, you have a group of data, some values, okay? If you find outlier, I will use what? The median. If I find there is no outlier, I will use the mean to describe this data. Okay, now we have some remarks to conclude this information. The first one, if the outlier values are smaller than the other value. Okay, so like what? Like I have this data, okay, and I have these dots like this, and just I have one value here. This value is to the left of the values. That's mean the value of the mean will decrease, okay, will decrease, because of this outlier is to the left of the group of data. But the opposite, if the outlier are greater than the values, if this dot are here to the right of this data, so the mean will decrease or will increase? Will increase. Okay, so the outlier to the left, the mean will decrease. The outlier to the right, the mean will increase. Okay. Number 3, the more number of outlier, the more effect on the mean. So I have this number line, okay, we have dot here and dot here. Okay, now if you have just one outlier, the value of the mean will affect. Okay, but if you have two outliers, there is more effect on the value of the mean. Okay, okay, we have some example to explain this matter. Okay, let's go. Example number 2. Find the mean. I will find the mean including outlier and without outlier. Okay, so I will find the mean two cases. The first one include outlier. The second one with no outlier. In each of the following set of data, what do you notice? Okay, okay. The first point, we have these values 5, 20, 25, 35, and finally we have 30. Okay, okay. Now to find the mean, but with outlier, without layer, equal what? To find the value of the mean without layer, you have to what? You have to add all values using the rule divided by what? The number of them. 1, 2, 3, 4, 5. That will equal what? That will equal, okay, we have 5, 25 plus 25 equal 50. 50 plus 35 equal 85. 85 plus 30. 85 plus 30, we have 100. 150. Okay, divided by what? Divided by 5. No, that's wrong. Again, we have what? We have 5 plus 20, that's equal 25. Okay, 25 plus 25 equal 50 plus 35, that's equal what? That's equal 85 plus 30 equal 115 divided by 5. 100 by 5 equal 20. Okay, and 15 divided 5 equal 3. So we have 23. Now I find the value of the mean with outlier. It's equal 23. Okay, the second case, to find the value of the mean without outlier. Without outlier. That means I will add all of these values without what? The outlier. So we have 20 plus 25 plus 35 plus what? Plus 30 divided by what? Divided by 4. 1, 2, 3, 4. That's equal what? Let's add. We have 20 plus 25 equal 45. 45 plus 5, 50. 50 plus 30 equal 80. 80 plus 30, that's equal 100. 110 divided by 4. Note with me, this 110 divided by 4 equal what? Without using calculator, okay, I have here 100 plus 10 divided by 4. Okay, 100 by 4 equal 25 plus 10 by 4. 10 by 4 equal 2.5. Equal 2.5. That's equal 27.5. Now, look with me. I find the value of the mean with outlier. It's equal 23. Okay, but without outlier, it's 27.5. Now, solve the second example. We have all of these values. First, I will find the mean with outlier. Okay, that's equal. I will find the sum of all of these values. Okay, so I have 2 plus 5 7 plus 1 8 plus 3 11 plus 3 equal 14 plus 5 19 plus 2 21 21 plus 40 plus 20 41 41 plus 20 61 61 plus 20 61 plus 20 equal 81 divided by the number of them 1 2 3 4 5 6 7 8 9 10. 81 by 10 divided by 10 equal 80.1. So the value of the mean without layer equal 80.1. 8.1. Stop. Okay, the value of the mean so here we have without layer, sorry, here we have without outlier. So I will delete the outlier. Look here, what's the outlier? The outlier here, all of this number of this value are close to each other, but these values so far from this number, so I will delete all of this because these 320 are outliers. So we have 3 outliers. I will delete all of them. So we have 2 plus 5 7 plus 8 plus 1 equal 8 plus 3 11 plus 3 equal 14 plus 5 equal 19 plus 2 equal 21. 21 divided by the number of them 1 2 3 4 5 6 7 divided by 7, that's equal what? That's equal 3. So the value of the mean equal 3. Now, what do you note? What do you note? I note that, okay, I note that the more number of outlier, the more effect on the mean. So here we have 23 and 27. Two cases are close to each other, okay, but here we have 8 and 3 so far from each other. So if you have just one outlier, here we have 5, but here we have 20 and 20 and 20. So the outlier is just one outlier. Here we have 3 outlier. Each time the outlier increase, okay, the effect on the mean will increase either. Okay, the more number of outlier, the more effect on the mean. Okay, now let's go to the note. So the note here, the more number of outlier, the more effect on the mean. Okay, look here for this remark. We have the following dot plot. Okay, we have 2 dot plot. Look here, I have just one outlier, but here we have 1 2 3 4 5 outlier. Here we have one outlier, here we have 5 outlier. So the outlier has small effect on the mean. Small effect on the mean. Why? Because just one value. But here we have 5 values as outlier. So here we have great effect on the mean. Just you find just one outlier, it's a small effect. You have 5 outlier, you have great effect on the mean because we have 5 outlier. Let's go. Now to understand, we will solve example number 3. Example said, how will the outlier affect the mean? You will learn how the outlier affect the mean. Use reasoning to assign each of the given description with the related graph. We have 3 options here. The first one, mean decrease, or mean stay at the same with no change, or the mean will increase. Decrease or stay or increase. Okay. Point A. Okay, we have this dot plot. Look here, we have just one outlier, but this outlier is to the left of all of these values. So the mean stay or decrease or increase? Of course, we learned before that if the outlier is to the left of the group of data, so it will decrease the mean. Oh, but here we have this outlier is to the right of this group, so the mean will increase. Okay, here we have point C. I have one outlier to the left and another one to the right at the same place. No, you can note that this plot are symmetry. What's the meaning of symmetry? Look here at 500. All of these values repeated here. Just a scale, okay? And just not in scale, it's balanced scale. It's balanced scale. So if you see this symmetric shape or symmetric graph, so the mean will stay the same. No change of the value of the mean because of outlier. Also here, look, you have at 4 and 5 as the same. And this shape here is the same here. 1, 2, 1, 2. Just 1 and 1. 4 and 4. So this dot plot are symmetric. So the mean will stay the same with no change because of outlier. We have some notes. Let's go. Notes that first point, if the data on dot plot graph is symmetric, like point C and D, okay, like C and D, then the mean stays the same with outlier or without outlier. There is no effect of outlier at the symmetric line, at the symmetric figure. Point 2, the outlier to the left side as figure A. So the mean will decrease. But if the outlier to the right as figure P, the last example, so the mean will what? Will increase. So the outlier to the left, the mean will decrease. Okay? But the outlier to the right, the mean will increase. Okay, to the left will decrease, to the right will increase. That's the effect of the outlier on the mean. Okay, let's go. Now, which is better to use, median or mean? Okay, so we have some graphs here. Okay, I will define for each graph which one is better to use, mean or mean, median or mean. So look with me. Look here to this graph and this one. You find what? This dot plot are distributed in one side of graph. So this graph we have these dots, okay, to the right of the graph, and here to the left of the graph, but it together as group of dots. Okay, in this case you will use what? You will use the median to describe this data. Okay, but if you find it as symmetrical, look here, that's symmetrical. This one called symmetrical. This half like this half. Look here, if you divide it by the half, you will find that these dots are like these dots. So we called it symmetrical graph. If you have some symmetrical graph, either you use mean or median, it's okay. The same thing, okay? But if you have what? You have some plot distributed evenly on two sides without symmetry. What? You have just distributed dots without symmetrical and without side. Not to the right, not to the left, no symmetrical. So, not these cases, these two cases, not like this case. This case is to the right and here to the left. We said to use what? To use the mean, the median. If we have symmetrical, use median or mean. But when it's distributed randomly, okay, I will use what? I will use the mean. The mean is the best way to describe this data. Okay, I have some example to check this point. Example number 4, choose mean or median or either, any one of them. Look here, these dots to the left of the graph. I will use what? I will use the mean, the median. Okay, the median. Now, B, this graph, no symmetric, and no to the right or to the left. So I will use what? I will use what? The mean or the median? Yes, the median. I will use the median. Okay. But look here, we have what? We have symmetric. This part like this part, right? So it's okay to use the mean or the median. I will call it as easier median or mean. Okay, last point, I have this shape. This shape are random distributed. Use what? Use the mean. Okay. Again, you have when you have dots on the right or on the left, I will use the median. When you have symmetric, either median or mean, it's the same. You have just random distribute, use the mean. But the question is here, why I use the median? Why I used the median, not the mean? Why? You know that we have here what? Outlier, right? And I know that outlier has a small effect on the median and the great effect on the mean. So if I use the mean, this dot will affect on the mean value, but there is no effect on what? On the value of the median. So if you have in your graph outlier, use what? Use the median. If you have symmetric, anyone. If you have group to the right, to the left, use the median. If you have it just random distributed like this one, I will use the mean. And this is the only case I use the mean to distribute a group of data. Finish the lesson, but the last thing, I will check all of these ideas. Okay, let's go. Check your understanding. First question, select the outlier in the data sheet. I have all of these data. Which one is outlier? Note with me. 22, 27, 25, 24, 26, 23, 99. What? 99. 22, 25. It's all 20s. But 99 is outlier. Okay? Point 2. Choose the best description of the mean if the outlier has been removed according to the following graph. Okay. Now I have this graph. Okay. And I have this outlier. So the value of the mean because of this outlier will decrease or increase or stay as the same. We know that when the outlier to the left of the group, the mean will what? Will decrease. So I will choose the mean will decrease. Okay. Point 3. Choose the best measure of central tendency you think to use. Okay. Look here. Here we have what? Look here. This group, like this group. And this group in the middle of these two groups. Not with me. So, this group in the middle. And here we have 9 empty here and 5 empty here. And we have this group, 3 group here, and we have 3 values here. At the same 3, 2, 1, 3, 2, 1, 2 and 2, and in the middle we have 4. This I call symmetric figure. When you have symmetric figure, what you use? Either the mean is correct and the median is correct, so I will choose either any one of them. Last point we have, find the mode of the given data sheet. I have 2, 4, 5, 2, 4, 6, 2, 3, 5, 2, 4, and 7. What? Find what? The mode. Okay. I have here 2, and 2, and 2, and 2. 2 is the mode. Just 2. Look. We have 4, and 4, and 4. We have 3, 4. 1, 2, 3, 4. So 4 is mode. Okay. And we have 5 and 5. We have 5 repeated. And what? Just 1, 6 and 1, 3 and 1, 7. Which one is the mode? No, the mode is the most often, the most one. So 5 repeated 2 times, 4 repeated 3 times, but 2 repeated 4 times. So the right mode is 2. 2 is the right mode. But if you have some value repeated the same number of the same times, so we have 2 mode. But this case, just we have 2 is the most repeated value is 2. So 2 is the right mode. Now we finished our check and we finished our lesson, and I hope you got time, and thank you. Goodbye.